Hi, and welcome to Physics Fundamentals. I'm your host, Angie. In this episode, you will hear from women in physics at Brown. You'll hear why they chose physics, and you'll hear a little bit about their research and their experience pursuing a physics degree.
So what inspired me in physics was my grandmother.
Oh, me too.
You too?
Yeah.
So my story was when I was in India, I shared a room with her. And she was super smart, super intelligent, and her mental math was amazing.
Wow.
And she taught me math in high school.
Really?
And surprisingly, she was married off at the age of 13, so
Oh.
she couldn't continue studies. But apart from that, she was still like extremely bright and intelligent.
Yeah.
What about you?
Yeah, my grandma was also my inspiration for continuing into higher education and even going to college. For me, that was the reason why. She didn't get a chance to go to high school. There was no formal schooling for girls at that time in Kuwait, which is where I grew up. But my grandma wasn't able to go to college afterwards either. But for example, her younger sisters were able to go and pursue higher education after high school. So for me, that's the reason why I decided to go to college and pursue a master's now, and in the future also a PhD. But physics, I really liked math. And that's one of the subjects that my grandma was also really good at.
I actually remember watching Westnall's lecture when I was in undergrad, and that is also one of the reasons why I came to Brown. Yeah.
Professor Mitrovic
Yeah.
also taught me quantum mechanics, and it was great to have a professor in my first semester here who can support her students for sure.
My name is Jade. I'm a first-year PhD student at Brown. I came here from Canada. I moved here a few months ago. I did my undergraduate studies at McGill, and I come from a family where nobody else went to university. I'm the first one who went to university in my family, the first one who went to grad school. My dad works in human resources, my mom works as a nurse. And when I was growing up, I didn't really have any particular interest in physics. I had an interest in reading. I liked reading about science, about, for example, dinosaurs. I really liked dinosaurs. And when I grew up, I thought that I wanted to be a veterinarian. And what made me want to study physics is when I took my first physics class in high school, and I just discovered that I was good at it. I liked it, and especially I liked helping others in my class. Especially my friends had trouble with assignments sometimes, and I would help them out with homework. And my best friend who wanted to get into med school, I helped her a lot. We sat down together at lunchtime, we would work on the problems together, and eventually when she made it to med school, to her top choice university, I think I was even happier than she was. So that really became my driving force, just this desire to help others learn physics. And when I enrolled at McGill, when I started my undergraduate studies, I joined a class. It was an introductory astrophysics class taught by a lecturer who eventually became my research advisor. And he was just a very good lecturer, very engaging. His teaching style really spoke to me, and I finally saw an image of what I wanted to be in the future. So he became my role model, and he also re-inspired a passion in astronomy for me.
I was very young. I was 11 when the Higgs boson was discovered. I was in the village with my grandparents. I didn't understand what was going on. Many grown-up people with these white colors on them, very happy about something that was not even pronounced the way it was written. At the time, I didn't speak English, so it was even harder to see what it was. I guess my interest kept going. At high school, I was just hooked up by the simple pendulum experiment the first day of my physics class. And then I kept loving physics, and I just figured that the best undergrad physics programs were here in the US, so I decided to change country.
So Rachel, why did you get into physics?
Two reasons. One, as a child, I was really into Star Trek. I saw Spock, I wanted to be Spock, and now I study astrophysics. Also in high school, I took calculus, and I really enjoyed just working through those problems and the mechanics of that type of work. So I decided coming into college, I should look into fields that were similar, and fell in love with physics.
That's awesome.
Why did you choose physics?
So my grandma is actually a physicist, and I spent a lot of my childhood summers with her, and her idea of a good time was doing science experiments together, and so she definitely influenced me from a very young age, and I think I was just very lucky to have a lot of good mentors throughout high school. I think my high school physics teacher really impacted me, and I think changed my life for the better. That's kind of why I'm here.
My name is Sarah Mueller. I am a laboratory physicist and an adjunct lecturer here at Brown University in the Department of Physics. My path through physics came through chemistry. I was a chemistry student as an undergraduate, and I really loved thinking about how molecules are formed and what it takes to make a chemical bond. How do these electrons get together and pair up? What I realized was everything that I loved about chemistry was actually physics. It was quantum mechanics. And so I switched my major into physics from chemistry, and I found out really quickly that I was the only woman there. And that was kind of alienating, and it was hard to make friends. And a lot of my professors didn't take me seriously. I had an instructor who told me that I wasn't cut out for graduate school, and that was really disappointing and discouraging. And then at the same time that all of that is happening, I'm having a really great time in the lab, in the instructional lab, and I had this moment where we were doing this canonical experiment. It's called the Millikan oil drop experiment. What you do is you spray these little oil drops in between parallel plates of a capacitor, and you can watch them, and you apply a voltage, and you can kind of suspend them in air. And based on what you know about the oil and what it looks like, you can figure out how much charge is on each individual drop. And it should turn out that you get the electron charge, because that's the fundamental charge in physics. And in our experiment, we were always getting about 3 times the electron charge. And that was really weird. We didn't expect that, and the instructor said, "Don't worry, this is how it always happens," but it really bothered me. And so I took the entire experiment apart, and I'm not entirely sure I should have done that. But what I found out was that someone had mismeasured the difference between the plates, the distance between these 2 parallel plates, and it was off by exactly the same factor that we were seeing in our data. And so I fixed that problem, and that was really the first time in my experience that I got to fix a problem in physics. And so, yeah, that was really impactful for me.
My name is Jessica Washington, and I'm a first-year master's student at Brown University. I started my first sort of endeavor into the astrophysics and cosmology world, or at least more accurately astrophysics, visiting the H.R. MacMillan Space Center in Vancouver, Canada, my hometown. And I visited many times with my mother and my schoolmates for field trips and things of that nature, as well as visiting the Vancouver Science Center plenty of times as a child. So a lot of my inspiration came early on from museums and interactive museum opportunities, and being able to explore these environments, kind of have self-led journeys through these really interesting parts of science and astronomy more closely was really what kind of piqued my interest and grasped my curiosities and kind of really nurtured my mind, I think, when I was very young. It's really funny, my mother has many stories of whenever we'd visit places like this, whether it be the Space Center or the planetarium. When we were getting ready to leave, she would turn to zip my brother's coat when we were very young, and the moment she turns around to look for me to say, "Okay, it's time to get ready to go," she'd find me gone, running off into the museum to find anything else to do, which I think really speaks to my initial interest and is a fond story that I think of whenever I think of my early experiences in that area.
Hi, my name is Brenda Rubenstein. I'm an associate professor of chemistry and physics here at Brown University. My love of physics goes back many years. Physics was one of the first subjects that showed me that you could use powerful theory, powerful ideas, and actually apply them to the real world. But over the years, I've really learned to love physics and learned to communicate my ideas and my physics because I found the confidence in myself through building powerful ideas to be heard. And so, sometimes when you're a scientist, people sort of think that you're in the back of the room writing different things out and coming out and coming up with brilliant equations. But a lot of it is interacting with your community, speaking with your peers, and communicating powerful ideas to those different people. And so it takes a bit of confidence to do that. And sometimes as women, we find it difficult to find that confidence in ourselves. But from being able to work with others and really to imagine things together and see a better world together, I grew more confident in myself and in my ideas. And so this is a powerful thing, I think, for many women is really being able to find that confidence in the thing that you love, whether it be physics, whether it be art, whether it be dancing, whatever it is. It's really important to find that confidence so that you can bloom. So if you're interested in physics, if you love physics, first of all, go in and learn that physics. Dive in, be deep. It's always important to be a master of your own discipline as best you can. But also work on developing your confidence, your communication skills. I think that's something, as I was mentioning earlier, confidence is sometimes something that women struggle with having for various societal reasons. It's important to develop that confidence. How should you do that? Go out, do projects, experience the field, experience life. Those experiences really help in shaping you and building you up. Find that success, and sometimes that success is in physics. Sometimes it's in some other area, but those successes complement each other. So even if you're successful, let's say, in some other pursuit, it really gives you the ability to translate that success into other things. And so I would say, master what you're doing. Be great at it, be excellent, but also develop the confidence to keep propelling yourself forward.
My name is Kanshida Klangbun-Krong. I go by King. I'm a first-year PhD student at Brown studying physics. I work with Professor Greg Tucker working on Excite. It's a balloon-borne telescope project that I'm a part of, and I'm really excited to see it launch very soon. So I am from Thailand, growing up in Thailand until I was 18, and then moved to the US for undergrad, and then I came to Brown as a master's student. I chose physics because physics can explain anything around us. I love reasons. I would love to understand why things happen. So I think that's why I chose physics, and I'm enjoying it. I love solving equations. I like math, and I like to explain stuff around me.
I'm Vesna Mitrovic. I'm a professor of physics and engineering. I'm actually condensed matter physicist, experimentalist by training, but so what I actually do is, I guess, try to uncover secrets of quantum mechanics and how that influences the world we live in and how it allows us to make very useful gadgets and understand the world around us. It was love at the first sight for me, very early on. And I find that there's something really fascinating about trying to understand deeply how things work around us and to be able to understand the inner workings of nature that are independent of how we feel about it or anything, how we perceive things. It's really what attracts me to physics. And it's a constant challenge. I kind of have a message for all the young people who want to do it, that don't let difficult things kind of block you. Yes, physics is difficult, and I know many people think that we all make you work very hard for no reasons, but it's really a beautiful subject, and there's nothing better than seeing at the end, after for years you've been trying to figure out a problem, but to see how just mathematical elegance leads you to understanding something so fundamental, where these formulas that seem just so disconnected and just endless give you allow you to really understand how things work out, how universe works.
When I was in high school, I'm more interested in math and physics. But when I entered college, I chose physics as my major for practical considerations. It seemed to me at that point physics could be more connected to the real world and there could be more job opportunities. And through my study, I really enjoy learning physics, so I decided to continue to pursue a PhD degree in physics. And throughout this process, I find myself really enjoy and good at doing research on theoretical physics. More importantly, I find I'm capable of making a living being a physicist carrying out research and teaching physics. So I think, why not become a physicist?
What specifically do you like to do in physics?
Okay, so I just started research, and I'm trying to join Richard Gateskill's group, and I'm interested in dark matter research, like astroparticle physics.
That's so cool.
Yeah. What about you?
That's like uncovering the mysteries of the universe. I work in condensed matter physics, and specifically within that subfield, 2D materials. So I work with Professor Jia Li, and he works with graphene systems. So we do cool stuff where we like twist different layers of graphene and some other materials, and we try to uncover what happens when we bring them to really ultra cold temperatures, even colder than space.
I also had to learn some programming because in physics you can't really get away from it. And I also found that I really liked that too. I spent a lot of time focusing on learning Python. I spent some time I did an internship in data analysis over the course of the summer. And during this internship, actually, I had the chance to lead a Python crash course. So for over the course of 10 weeks, I prepared lessons, I prepared exercises, solutions, references for the employees at the company who wanted to get up to date with technology. And I think I found I enjoyed that even more than the internship itself. So for me, teaching has always been important. When I was younger, I gave swimming lessons at the pool next to my house. And growing up, when I was a little older, I started tutoring high school students in math and physics. So it's always been really important for me. At first, because it brought me a lot of joy to see the students learn, to see the students improve. And eventually I found that it also helps me to understand the material better, especially, for example, in physics. When I teach physics, I understand physics better, and that makes me a better physicist, which makes me a better teacher, which makes me a better physicist again. So it's just a positive feedback loop that continuously helps me improve.
And so I work in a low-dimensional electronics lab where we build superconducting devices out of twisted multi-layer graphene. And for my thesis, I'm also using density functional theory, which is a simulation technique to analyze the system computationally and try to see where the computational simulations fall short relative to our experimental data. How about you, Rachel?
My senior thesis is in dark matter substructure detectability in galaxy clusters. I'm working in Professor Dell'Antonio's group. And there's an observatory opening soon, I think this year actually. The Vera C. Rubin Observatory, named after the woman who helped really popularize the theory of dark matter. And I'm using their software analysis pipeline on simulated images of weak gravitationally lensed galaxies to determine how good we are and what our detection thresholds are for dark matter substructures. So when we then apply it to real data, we know, okay, our mass reconstruction isn't super reliable, but our location accuracy of where the substructure is and how much substructure we might be missing, like percentage-wise, if we're only detecting 50% of dark matter halo at a certain mass range. If we get one, we might know that there's another we're missing in the image somewhere.
That's very cool.
So I took a gap year, I did some lab work, I went to graduate school, and as I was doing all of these things in condensed matter physics, I was really thinking about what is preventing people like me from studying physics, because I knew it couldn't just be individual instructors discouraging people. And so I got into physics education research, and that's a lot of what I do now, is building up these instructional labs so that students like me can have experiences like I had and like really see themselves as physicists.
So I'm someone who lives at the interface between chemistry and physics, and I do what I would call theoretical condensed matter physics. I would mostly classify myself as that. So a lot of times chemists say what I do is physics, and what physicists will say what I do is chemistry. But what I do is I try to think about how real materials will behave. So we make theories, and we also do a lot of modeling that suggests, how will this quantum material behave in this environment? What kind of phase transitions would it have? Would it be magnetic? Would it deform under different conditions? And so we try to predict those things basically from scratch. And you might ask, if we're thinking about quantum materials, isn't that all physics? Well, the part from scratch, it really comes from chemistry. And so I sit at the interface between them because chemists like to think about at an atomistic level, what would happen to your material? So I kind of bring that attitude into physics. And that's a very powerful attitude because it allows you to think, from scratch, building up from the bottom, exactly what is your material going to do? And if you change it in these ways, what would happen to it? And so my work readily feeds into experiment, as I was suggesting. So we oftentimes collaborate with large teams of experimentalists because they want to know, if I go into the lab, what's going to happen? And so the theories that I create and the modeling that my group does allows them to understand what they should be seeing and what happens if they don't see it. What does that actually mean?
I'm working on a balloon-borne telescope, so that's really fun. It's about astrophysics instrumentation, so I get to actually build a telescope, part of a telescope, and then putting it together. And the whole point is to send it to Antarctica and launch it attached to a balloon, and then launch it to 40 kilometers up the sky. So that is the plan in the future. I am a part of Women in Physics organization at Brown. I am the chair of that group. I've been working with a lot of other females in the department, and I am really thankful for them. So last year I got to work with Professor Meenakshi, Narain, organizing QWIP, Conference for Undergrad Women in Physics, and that is also one of my passions. Other than physics, I would love to make this space to help other females who feel more comfortable in the field. And this year, I also get to work with Professor Volovich. She became the new advisor in the group, and she's really excited to be there. And I love to have other female faculty to just talk to them, talk to their experience.
I joke with my students that I spend these days, I used to work in a lab a lot, and nowadays that your group grows and you have more ideas and you can risk more when you become older, is that I tell other people what to do. So meaning what we're trying to do is that we're really trying to understand on a very basic level how to, properties of materials, how quantum mechanics works when you have many, many, many electrons. We all know, or we heard the words of entanglement and how beautiful that is and how it's going to allow us to have this telecommunication that nobody can ease in, so it's all safe. But that only works, or at least we have a test to know whether this quantum entanglement, this beautiful thing, actually exists for two particles. But then every material that we have, everything we have to work with, there are 10 to the 23rd, many, 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 many particles. And so this notion of, can we actually have something useful in there to use it, is what fascinates me, to try to figure it out and how to exploit it. And there's something fundamental that tells us that, what we see is just one particular property of the material in one measurement. So quantum holds a lot of properties to give us this amazing revolution, but yet it fundamentally prohibits us from knowing what that is and how to really measure what is the most fundamental about it. And that's kind of a conundrum. How do we, how can we use these things, but we don't even know what it is? So this is where I spend my life, obsessing about how to, not really, I wouldn't use the word fool, but in a sense that's how it is, how to win against quantum mechanics and actually learn something about real materials that, it's almost prohibited by standard techniques that we have, by, the way we view physics. So, in a nutshell, that's what I do.
So do you like here at Brown?
Yes, I like the supportive environment. I like that the group of people that I've chosen to spend most of my time with are very supportive of me. How about you? I know you've only been here for a few months now, but so far.
I think it's amazing as compared to where I was before. Here, people are supportive, and for example, in group discussions and when I sit with my classmates to work on homeworks, I feel included and my opinions are respected, and I'm just involved. So I love it over here.
Do you want to continue with physics, you think?
Definitely, if I get an opportunity.
Me too.
So I decided to study at Brown because I always lived next to Montreal, and I decided that it was time to go out and explore the world a little. I'm naturally a little shy, and I wanted to get out of my comfort zone and just have as many experiences as I can. I thought it would be good for my personal, professional growth, and I don't regret the decision I made because I made some connections here, and I've already started having experiences that I don't think I would have had the chance to have if I'd stayed home. And for example, at Brown we have an observatory where we have some telescopes, and I've been learning how to use the telescopes, how to take images, how to process the images, and as an aspiring astronomer, I'm really happy that I'm finally getting into astrophotography. I don't think I would have had the chance to do that otherwise. So I'm really glad I chose Brown for this reason.
And I am very happy that I've been at Brown through my undergrad experience, because we do have so many great undergrad research opportunities. Indeed, last summer I have been working with Professor Landsberg Alanutra in LHC collaboration in CMS. So I've been kind of doing what I have dreamt when I was 11. And the other good thing about passing this time at Brown has been that I did not really face any overt or blatant discrimination against my gender. I'm very happy at Brown. I love it here. And indeed, we have a great physics department.
But yeah, so what has been like your most favorite part of physics at Brown?
The friends I've made along the way.
Me too.
And also just I've gotten to do some really cool interdisciplinary work. I took a course on choreorobotics, which is the field of teaching robots how to dance.
That was cool. I remember that.
It involved a lot of taking physical concepts and applying them to this robotic system, and also trying to incorporate artistry and my dance practice I do outside of physics.
I think the interdisciplinary aspect of the physics education at Brown is very true. I think I've experienced that too, and it's been cool because I think I've made such amazing friends who have encouraged that, like yourself, and also I've had amazing mentors who have encouraged that as well. So for example, I work in Dr. Lee's condensed matter experiment lab, and I became interested in theory as well and computational techniques, and I've had the chance to bridge that gap between experimental work and computational work for my senior thesis, and there's a lot of freedom, and I think that the mentors that I've met at Brown have truly made my experience unforgettable. I think I don't regret this degree at all. I think the cool thing is that it gives you a grounding to be able to learn anything. Yeah.
So what I really love about working at Brown is that I get to do all of these instructional labs. I get to make new labs, and with individual students, we can chase things that we're interested in. It doesn't have to be fixing broken experiments from decades ago. We can look at new and interesting things inside of the instructional lab.
And I love Brown University because it feels like the exact place I'm supposed to be right now at this point in my academic career. I feel equipped to take full advantage of the amazing resources that I've been given and use that to apply to the unique things that I bring to physics, and to be able to go off into the world as a physicist and be able to contribute some real exciting stuff and to be part of projects that are really exciting. So I'm so glad to be here because it just feels like the right next step.
It's amazing to also be at Brown and do physics. So there are many places I've been where it was definitely hard being a woman and doing physics. But at Brown, there are many other women doing physics and doing physics at a powerful level, and that's sort of an amazing thing. And there are a much wider network of people who are extremely supportive, who think about the future in ways that at some other places people don't. And that supportive network has really made it possible for me to be successful here at Brown as a physicist in general.
I love being at Brown because Brown support me. Not just physics department, the graduate school itself. I have a lot of friends outside of physics, and I think Brown, even though it's a small school, Brown made me comfortable, made me feel like I'm at home. I can do anything if I have people supporting me, and I do think that the department support me in a lot of ways, and I find a lot of good friends here. I would say I will probably find a lifelong friends that even when I'm graduate, I will still keep in touch, and even with a bunch of professors and friends outside of physics. So that's why I chose Brown, and I'm glad I did that.
First to say, why am I here at Brown, and, very happy that we have freedom to do our research, that the quality of the students that we get to work with is really amazing. And that also brings me to, I always say that the reason why I'm here is that, it's my colleagues as well.
The thing that brought me to physics in the first place is because of the powerful way that physics brings together great ideas and great experiments. So there are many fields that are either highly theoretical, won't name names, and there are many fields that are very experimental. You really have to go into the lab, otherwise you have no idea what's going to happen. But physics is in this interesting middle ground where theory can really talk to experiment. So you can figure things out on the board and come up with really simple but powerful ideas, and then actually translate that into the lab. Particularly in condensed matter physics, you can realize something amazing about what the electrons do that maybe nobody else thought about before, and then you can go into the lab, make the material see it actually happen. And that was a very powerful combination for me. And it's something that can happen actually in your lifetime, particularly in condensed matter physics.
Doing physics is a marathon. As we like to say, for those of you who have ever climbed the mountains or hiked or biked in the mountains, it's like going to mountain passages. So it's constant up and down, and it's really worth it enduring. If I had to do it again, I would, all over again. We had a discussion actually at the conference that Meenakshi organized about how students would see these successful professors and think that we just it was easy for us, and all of us, as I said, agreed that what you don't see behind the scenes, that all the failures, that for every success there is about 10 that and how we felt at times really helpless and hopeless, but you just have to keep going, and at the end things do work out, and that's what you see as the end result. But this is really not a reality, and I think no matter what you do in life, maybe a little bit more in physics difficulties than others, but or in science on that level for that matter, but no matter what you do, you will have ups and downs. Nothing is ever easy, and the more difficult it is, the more enjoyable at the end when you succeed you feel, and more accomplished.
When this professor told me that I didn't have what it takes to go to graduate school, I think I was mostly confused because I was doing so well in my courses and I really enjoyed the work that I was doing. And it wasn't advice that he was giving any of my peers. So all of the other students were told that they could do it. And then, simultaneously, there are these other counterbalances. And I had another instructor, in a related field, basically tell me, if you want to do physics, do physics. You can always come back to chemistry. Chemists will take you seriously as a physicist. But if quantum mechanics is what you want to learn, go learn it. So I think that, part of what feels scary about people telling you that you can't do something is that you start to believe a little bit of it. And so it's important to find those counterbalances that if you want to do it, there's nothing preventing you from doing it. I think that If I had to give advice, it would be to find some community. Find people who want to study the same things you want to study, who think about the things you like to think about, who want to work on the problems you want to work on, regardless of if they're in physics or if they're broader than that. Because we're people who do physics, and so you have to find your people.
Of course, there were subtle things among my peers, sometimes from the greater physics community, such as not being included in the conversation, or being interrupted more than guys, or sometimes not being looked at while my question was being answered. Small things that were indicators of the failure of acknowledging my presence in the area. But I cannot say I have faced anything major that really discouraged me from pursuing physics, and I think I am one of the luckiest people to have had this experience, and I hope this starts not being a luck but the norm, that we all have the same experience as guys while pursuing physics.
When I moved to the US 8 years ago, I faced challenges being female in physics. I started at Penn State in our class. When we started freshman year, there's like 40 total, and then there's like 5 female students. Just being in the space that don't have a lot of females surrounded me, it feels sometimes uncomfortable. But I do think now, like looking back, looking at undergrad right now, looking at graduate grad school program in physics, you see that the ratio of female is like really female to male just go up, and I do think that we're going in the right direction, but I do have some experience that I hope no one else has to go through. I would recommend, if you ever face any challenges being a female in physics, to reach out to either female friends, women professors, or in your university or even any other universities. You can just email anyone, and I'm sure that they will be happy to talk to you through it and find your support system, because I think that's really important. If you have your support system, you can move through this, you can move forward and become successful in physics.
So this is not always a smooth journey. I encounter I have to overcome both internal and external obstacles. So the internal obstacles comes from self-doubts and loss of confidence. In particular, when I was younger and got stuck in a research project. There were moments I questioned myself whether I could continue and become a physicist. The external obstacles could come from many different origins, in particular from failing to get recognitions from others in the same field. This could be due to different opinions and viewpoints, and this could also be due to implicit or explicit biases and discriminations. It is actually difficult and requires collective efforts from the entire community and even the entire society to correct some of these biases and discriminations. But at least at a personal level, as I become more mature and know how to handle better the challenges in research, I'm gaining much more confidence and it become more comfortable being myself.
As a Black woman and someone who is becoming, through my studies, increasingly more and more interested in belonging and understanding our place in the physics world, it's absolutely important that we understand that because this is something that truly fundamentally is so accessible to all of us, that it can be difficult to find yourself in the physics world and find a mirror of yourself. And finding representation has been something that I've been dealing with for my whole career and will continue to deal with for the rest of my career, but I think it's important to understand the capabilities that we have within this type of science. No matter where we come from, no matter if you feel like you cannot see someone that looks like you, they're out there. And it may feel like a very personal journey at times to try and go inward and try and build your belonging from inward, but from inside yourself at least, and try and build your belonging from what you understand and what you hope you understand about the physics world. But what is really valuable is to understand that scientific inspiration can come from anywhere. Scientific inspiration does not have to be a specific scientist, it doesn't have to be an astronaut, it doesn't have to be any of those things, even though it may be, and it was for me, definitely. I had quite a few inspiration in those areas, but it can come from all sorts of different places. Even though you may face resistance, even though you may face adversity, you will persevere through these things because it is within you, it has always been within you, and there are so many people who, even though you may not know who they are, they're rooting for you. Me being one of them. Anyone out there, I would hope by being a part of this and by being just a small part of a department and this video that's doing something so great like this, I could only hope to inspire others, because that's exactly what I wanted to look for and wanted to see, and I'm so excited to be able to be included so that I can be maybe that first person that someone's seen who's a Black physicist. So I encourage you to continue with your studies and to persevere through and to stay not only in your own corner, but find others around you and help them to recognize their own unique contribution that they can bring to the table. Whatever dreams you've had, whatever you think is going to be the next step for you, whatever in the deepest recesses of your mind you thought, I wonder if I could do that, you can. Take your time, take your space to dream. Don't be afraid to dream, because your dreams may take you somewhere you could never even imagine.
This episode would not be complete without a tribute to Meenakshi Narain. Meenakshi was the first female chair of the physics department at Brown. She was a trailblazer in her career and a mentor to many women in physics. Gigi will talk about her career, and Vesna will talk about her life and legacy.
So, Meenakshi is an experimental particle physicist and a fellow American Physical Society. She got her PhD degree in physics from Stony Brook University. She was then a visiting fellow at Cornell University and later a Wilson Fellow at Fermi National Accelerator Laboratory. She was a junior faculty at Boston University before joining Brown University. So Meenakshi had been conducting research with the CMS experiment at a Large Hadron Collider at CERN, located in Geneva, Switzerland. She studied the interactions of subatomic particles at a length scale, which is 1 part in 10 trillion of the diameter of a thick hair. She was instrumental in the discovery of the top quark in 1995. The top quark is the heaviest elementary particle that has been discovered so far. Meenakshi also participated in the discovery of the Higgs boson at CERN in 2012. The Higgs boson is the last missing piece of the standard model of particle physics.
Now to just give a little homage to my colleague and friend, Professor Meenakshi Narain, that unfortunately left us too early. She was our first female chair. But other than being a great scientist, it was really the person that cared to be a great role model, but starting modeling and being an excellent scientist and then requesting from her students to really be better than her. She always said in private that her job is to make sure that her students become better scientists than she is, and then, this is how we feel that, we are successful. And at Brown, we actually have students like that are willing to put up with us and then produce really amazing work at the end. And, there's nothing better than, being we're paid to learn. Our job is to internally learn, and I don't think there is anything better you can do in life. And I also want to say that Meenakshi, how she really helped students and female mentor many of them, and really understood what many of the obstacles are, and provided mentorship, provided tutoring for really, these horrible problems that we have to all do, and we don't see the reason why, and how that trains us to become later on really a great scientist. So I think that any students of hers that she trained, the only thing they can do for her is try to be really amazing scientists that would make her happy. And all those female students, especially that she mentored, who are doubting themselves and whether they can endure in this, we have to do this in every job, but think of her, and if there's anything we can do for her is to make sure that you carry the legacy and continue in physics and be successful.
You're very special in many ways. My message to you today is to start each day with positive energy and believing in yourself, and watch the magic happen. Never stop growing. Keep learning, keep exploring, and challenging yourself. You are our future. Congratulations.